Hello everyone, this is Dr. E and for today, pag-uusapan naman natin kung paano tayo mag-calculate at magsosolve ng similarities ng ating mga triangles according to its altitude and hypotenuse. Gagamitin naman natin ngayon yung ating mga theorems about right triangles at yung altitude ng ating mga triangles by manipulating or rotating yung ating mga given triangles para makuha natin yung mga line segments na kailangan nating hanapin dito sa lesson natin for today. So sa ating mga triangles na hahanapan ng solutions, kailangan natin gumamit ng ilan sa mga theorems na medyo komplikado kapag babasahin pero kung i-visualize natin, mas maiintindihan natin ito. So itong ating first theorem, which is yung altitude of a right triangle theorem, sabi dito, the altitude or the altitude to the hypotenuse of a right triangle divides the triangle into two triangles that are similar to the original triangle and each other. So sinasabi lang dito na kung meron tayong isang main right triangle, so we can illustrate it para mas makita natin yung ating right triangle. So itong right triangle natin ay kakaiba dahil nakahiga si right triangle. So right triangle ito dahil ito yung ating right angle at ito yung ating opposite side. So let's say na itong right triangle na ito ay right triangle A, B, and C. Now kung meron daw tayong altitude or height ng ating right triangle at tawagin natin itong CD, makakabuo tayo ng dalawa pang right triangles na similar doon sa ating main triangle. At ito lang yung sinasabi ng ating altitude of a right triangle theorem na kung saan makakaproduce tayo ng mga similar triangle given na yung ating height or yung altitude ng ating triangle ay magiging perpendicular bisector ng ating main triangle. So makikita ninyo na yung ating triangle ABC ay nagkaroon ng sub-triangles na ADC at CDB at itong mga ito ay similar or proportional sa ating main triangle na ginawa at ito yung ating altitude of a right triangle theorem. So for example, meron tayong ganitong uri ng triangle at mapapansin natin na parang similar siya doon sa ating example doon sa theorem at ang gagawin lang natin dito is hihiwalayin or we're going to separate this particular triangle so that we can produce similar triangles from the main triangle X, Y, Z na meron tayo. So ito yung ating solution na gagawin. Visual na lang yung ating solution. So yung ating main triangle X, Y, Z ay similar doon sa mga triangles na nabuo doon sa loob dahil mapapansin ninyo yung ating triangle na yan kung paporma natin siya ng pahiga, so ito yung magiging itsura ng ating triangle or given triangle XYZ. So XYZ at ito ngayon yung ating WZ or WZ line segment at ito yung ating mapuproduce doon sa ating mga triangle. So ito yung naunang triangle, yung mas malaki. Ito yan. Ay similar doon sa triangle na mas maliit, which is this one. And ito ngayon yung ating mga triangles na produced gamit yung ating first theorem of the day which is telling you na makakaproduce tayo ng mga similar triangles sa ating right triangle given that yung ating angle ay naging perpendicular bisector doon sa ating height ng ating given right triangle. So let's try another right triangle dahil mga right triangles ang pag-uusapan natin and its similarity at yung susunod nating mga theorems ay yung tinatawag nating corollary or yung supporting theorems na pwede nating gamitin gamit ang geometric means. At sa geometric means, sabi dito, for any two positive numbers A and B, the geometric mean of A and B is the positive number X such that A over X is equal to X all over B. So mapapansin nyo na similar yung ating first or second diagonal. So sa geometry, ito yung tinatawag nating geometric means at ito naman yung tatawagin nating extremes mula doon sa ating previous lesson. So when this happens, we'll be able to solve for the values of X knowing that the value of A and B are two positive numbers. So let's say meron tayong example na 6 and 15 at ito yung geometric mean ng ating ratio. So kung gagamitin natin yung ating proportion na A over X is equal to X all over B, knowing that A is equal to 6 and B is equal to 15, not 16. Then, if we have A all over X is equal to X all over B, change natin si A ng 6, change natin si B ng 15, and by cross multiplication, we'll be able to find the value of X. So magkakaroon tayong 6 times 15 is equal to X times X, and 6 times 15 is 90, and X squared. And by taking the square root of both sides, we'll have the positive and the negative square root of 90. But this time, since we're talking about lengths of a triangle, hindi na muna natin gagamitin si negative value at yung positive value ng square root of 90 ang gagamitin natin sa ating measurement. And we can still simplify this because we know that 90 is 9 and 10. And by doing so, we'll be able to get the square root of 9, which is 3, and yung square root of 10, which is just square root of 10. So ito yung ating simplest form ng ating values of X gamit yung ating example na 6 and 15 as the value of A and B, and by using our knowledge about the operation of rational expressions or rational equation, pwede natin masolve ang value ng X, which is square root of 90, and again, yung positive value lang ng square root of 90 yung gagamitin natin. Excuse me. And then by simplifying square root of 90, we'll have 3 square root of 10 as our value for this geometric mean. Now, gagamitin natin yung method na yan para mag-solve ng ilan sa mga triangles na meron tayo ngayong araw na ito. So, ito yung ating first corollary. At dito sa first corollary natin, mapapansin nyo na meron tayong line segment na CD na sinishare noong ating dalawang sub-triangles given our main triangle A, B, C, D. And when this happens, we can use this theorem para ma-solve yung ating mga missing lengths ng ating right triangle given this particular situation. So, yung ating triangle na ito, mapapansin nyo na yung ating forma ay hindi naka-rotate doon sa ating forma na mas familiar tayo. At yung sinasabi kong forma na yan is yung triangle that is looking like this. So we know that this is our right triangle at meron tayong line segment dito na nakakabuo pa ng dalawa pang right triangles, and when this happens, meron tayo ngayong measurement ng ating diagonal or height or yung altitude ng ating right triangle at yung ating subsegment ng ating hypotenuse dahil nahati siya into two measurement which is 8 and 2. At since meron tayo ngayong diagram na ganito, mas madali ko ma-visualize yung aking ratio na corresponding sa ating given right triangle. Wherein, yung ating line segment o yung ating height or yung altitude, which is common, the common line segment ng ating two sub-triangles, pwede natin siyang gawing means. So ito yung ating 4 and 4 at yung ating mga line segment ng ating hypotenuse, ang pwede nating ipalit dito sa ratio na ito. So yung first line segment ng ating main hypotenuse would be equal to 2 at yung susunod naman, yung other part would be 8. Not half, but just the other half of our other part of our hypotenuse. So ito na ngayon yung representation ng ating proportion using this corollary dahil nagsishare sila ng kanilang line segment CD or yung ating height ng ating right triangle ay given dito sa example na ito. So ito yung pwede natin gawing setup whenever we encounter a right triangle na merong given height dito sa ating example na ito. So ito yung ating corollary number 1 at yung corollary number 2 naman natin, ito naman yung ating triangle na kung saan mapapansin ninyo yung line segment doon sa gitna which is yung ating height ng ating right triangle ay hindi given. And when this happens, pwede natin gamitin yung corollary number 2 to produce the proportion of our right triangle that will help us in solving the similarity ng triangles na ito. So for this example, meron tayong triangle na buti na lang nakaporma na siya doon sa forma na mas komportable tayo. So ito yung ating line segment na nakabuo ng dalawang right triangles, and we know that this is our main right triangle at ito yung ating hypotenuse, at yung ating hypotenuse ay meron dalawang sub-segment. Ito'y 1 unit, yung unang line segment, at yung susunod na part ng ating hypotenuse ay 4 unit naman yung given from here up until the very end. So when this happens, mapapansin nyo na meron tayong given line segment dito na 2. So ibig sabihin, pwede natin gamitin ngayon sa corollary number 2 since hindi given yung ating height. Pwede natin gamitin itong proportion na ito, which is hypotenuse all over leg equal to hypotenuse all over the leg. So itong ating unang set ng ating proportion will be our main right triangle, at yung ating main right triangle has a hypotenuse of 4 kasi from here to here daw it's 4 units, at yung ating leg naman ng ating main right triangle will be equal to 2. Now, yung ating second proportion naman, ito naman yung pagpipilian natin yung dalawa nating triangle. It's either using this side, this triangle, or this side of the other triangle. And between these two triangle, mas kompleto yung given measurement nitong triangle na ito. So ito yung gagamitin natin. Meron tayong measurement na 1 and 2 dito sa sub-triangle na ito. So yung ating hypotenuse dito na gagamitin na proportional doon sa ating right triangle, pwede natin gamitin dito si 2, at yung leg naman nito ay 1. So ito naman yung proportion na gagamitin natin dahil similar nga yung mga triangle sa loob ng ating main triangle. So ito ngayon yung proportion na pwede natin gamitin kapag meron tayong encounter na triangles na kailangan sukatin na similar dito sa setup ng right triangle na ito. At ito yung ating corollary number 2. So meron tayong 1 wherein given yung ating altitude, at meron tayong corollary 2 wherein yung ating altitude ay hindi given. Instead, yung leg ng ating main triangle ang given information doon sa ating similar triangles. So let's use these theorem and 2 corollaries para dito sa triangle na ito. So dito sa triangle natin na ito, alam natin na mag-a-apply yung similarity theorem using yung altitude dahil ganito yung forma ng ating right triangle. And again, every time na mag-solve tayo ng ganitong right triangle, mas mainam kung i-rotate natin yung triangle natin para mas makita natin yung ating isosolve. And since kailangan daw nating hanapin yung value ng x and y, una nating hanapin yung value ng y dahil in this particular example, mas madali yung pagkuha ng corollary number 1 when the height of our right triangle is given. Height or yung ating altitude. So, ang gagawin natin dito, may altitude ang ating right triangle. Kaya, isolve natin siya sa forma na mas alam natin. Ito yung forma na yan. At alam natin na yung altitude ng ating triangle na yan ay si y. At meron tayong sub-segment ng ating hypotenuse which is 12 and 4. So, this is 12. And this is 4. Dahil mas mahaba ito. So, let's gawin natin mas accurate doon sa ating diagram. So, ito si 12 at ito si 4. So, when this happens, yung ating proportion na gagamitin would be yung ating geometric means, which means na nagsishare siya ng ating leg with y. So, we can use this setup at yung ating segment ng ating hypotenuse would be 4 and 12. So we can use the first segment here, 4, and the other segment here, which is 12. And it doesn't really matter kung ano yung mauna sa inyo dahil pag cross-multiply nyo naman sila, parehas pa rin yung lalabas. So don't worry about interchanging the value of 4 and 12. So by cross-multiplication, we'll be able to produce an equation that is now 4 times 12 equal to y times y. And by cross-multiplication and simplifying our equation, pwede na natin makuha yung y value na hinahanap natin. So si y, yung ating means at yung ating extreme would be yung ating line segment ng ating hypotenuse, which is 12 and 4. So by using these two values, again, tulad ng sinabi ko, kahit i-interchange yung values na yan, using corollary number 1, parehas pa rin yung value ng y na makukuha natin. So by cross-multiplication, now we have y squared is equal to 48, and by taking the square root of both sides, we now have square root of 48, at pwede nating i-simplify si square root of 48, kaya yung mastery nyo ng multiplication table ay napakahalaga dahil pwede natin i-factor out si 48 ng may perfect square, at ang perfect square niyan would be 16 times 3, at yung square root of 16 will be equal to 4, kaya yung ating y value can be simplified into 4 square root of 3. At ang hahanapin na lang natin ngayon is yung value ng x. So this time, iibahin natin yung forma natin ng ating triangle. So tatanggalin natin si y, and when that happens, ibig sabihin nun, wala na tayong information ng ating altitude. Kaya, gagawan natin siya ng paraan using corollary number 2. So paano natin ipoporma yan? So ito yung ating right triangle. At ito yung ating line segment y. Pero, alam natin na yung y natin, ang halaga lang niyan ay nakakapag-produce siya ng dalawang similar na right triangles. But in this case, yung value ng x yung hahanapin natin, at si 4 at si 12 ay yung sukat pa rin ng ating right triangle. And when this happens, gagamitin natin yung ating hypotenuse over leg proportion para makuha yung tamang equation na makakatulong sa atin sa paghanap ng value ng x. So ang una natin gagawin is yung ating main triangle, at yung ating main triangle would be our first proportion, at yung ating main triangle, ang hypotenuse niya would be 4 plus 12. So 4 plus 12 is equal to 16. So ito yung ating first hypotenuse, at yung leg naman natin would be the value of x dahil ito yung ating main right triangle. Kailangan na lang nating hanapin is yung ating second or sub-triangle mula dito sa ating main triangle. And again, dito sa dalawang triangle na yan, between triangle 1 and triangle 2, alam natin na mas meron tayong information dito sa triangle na ito, at sa triangle na ito, meron tayong value ng hypotenuse, at alam natin na ang hypotenuse ay opposite side ng ating right angle. So ito yung ating x. At yung ating leg naman ay 4. At ngayon, meron na tayo ngayong equation na makakatulong sa atin sa paghanap ng value ng x. So by cross product, so we have 16 times 4 equal to x times x. At ito na yung tutulong sa atin sa paghanap natin ng value of x. And by doing your math and making sure na alam ninyo yung inyong mga multiplication table, napakahalaga na ma-simplify nyo yung ating mga radicals. And of course, being able to write our equation correctly given by the triangle na meron tayo. So yung ating main equation mula dun sa ating main right triangle at yung ating sub-triangle, nakapag-produce siya na equation na 16 over x equal to x all over 4. And by cross product, we have x squared equal to 64. And kukunin natin yung simplest form ng square root of 64. And we know na yung ating simplest form yan would be 8 dahil perfect squares is 64. So ngayon, meron na tayong value ng x at value ng y, which is 4 squared of 3 and 8. So, ganyan natin ginagamit yung dalawang corollaries na pwede natin gamitin as long as yung ating right triangle na given ay papasa doon sa altitude theorem na meron tayo na kung saan yung isang triangle nakapag-produce tayo ng tatlo pang right triangles mula doon sa ating altitude na nagpo-produce ng dalawa pang right triangles tulad nitong example natin dito. So itong example natin dito, meron tayong science experiment. So how far does the robot travel from A to D? So si A to D, makikita ninyo, yun yung ating value ng X na hahanapin at meron tayong given information dun sa ating right triangle. So given itong ating isa sa mga legs ng ating right triangle at yung line segment ng ating main hypotenuse which is 9 inches. So hahanapin na lang natin ngayon is yung kaparte, hindi kalahati, but kaparte ng hypotenuse ng ating right triangle. And in this particular case, alam natin na yung ating line segment DB ay perpendicular doon sa ating altitude na na-produce mula dito sa ating right triangle. So, without further ado, let's use corollary 1 or 2 dito sa triangle na ito. And alam natin na hindi natin gagamitin si corollary number 1 dahil wala tayong information about the height nitong ating right triangle na ito. So, si corollary number 2 ang gagamitin natin. And with that, kailangan lang natin ma-produce yung tama nating equation given this triangle. So, we know na ito ay x, we know na ito naman ay 9, at alam natin na ito ay 20 inches. So, in this case, yung ating proportion na hahanapin ay hypotenuse all over leg equal to hypotenuse all over our leg. So, ang ating value ng main hypotenuse ay yung sum ni 9 and x. So, meron tayong 9 plus x sa unang proportion at yung leg natin would be 20. So, ito yung ating first proportion, 9 plus x all over 20. At hahanapin natin yung second proportion at alam natin between the two sub-triangles na meron tayo, pipiliin natin yung triangle na ito dahil meron tayong dalawang information which is 20 and x. So, yung ating hypotenuse ay opposite the 90-degree angle. So, meron tayong 20 all over the value of x, and ito yung napakahalagang equation na kailangan natin para maumpisahan natin yung pagkuha natin ng value ng x, which is the distance between A and D. And now that we know our value of our first equation or yung ating forma ng ating equation, which is solved using corollary number 2. So, alam natin yung ating means ay 20 at alam natin na yung ating main hypotenuse is x plus 9 at yung ating other leg dun sa ating sub-triangle would be x. So, when this happens, ang gagawin na lang natin is cross-multiplication. So, when we do cross-multiplication with this particular equation, makakaproduce tayo ng quadratic equation dahil meron tayong x plus 9 all over 20 and 20 all over x. So by cross multiplication, we have x plus 9 times x equal to 20 times 20. So we know we have x squared plus 9x equal to 400. And now we have x squared plus 9x. Para makita natin na inequate natin siya sa 0, we subtract 400 on both sides so that we have a quadratic equation equal to 0. At ang gagawin na lang natin is isosolve yung value ng x by factoring. Kaya mahalaga na na-master natin ang ating multiplication table to produce our factors para dito sa ating equation. So, alam natin na kapag negative yung last term, ibig sabihin nun, isang term natin will be negative and the other one would be positive. At ang kailangan na lang natin is yung factors ng 400 wherein two numbers na pag minultiply natin will be equal to 400 pero pag inadd natin will equal to 9. At yan yung pinaka-challenge natin, and to be able to help us find the factors. Kung ayaw nyong ma-frustrate, bibigyan ko kayo ng technique for the day. At ang technique natin for the day is using Desmos para matulungan tayo sa paghanap ng factors kung medyo nahihirapan tayo ng konti sa multiplication table natin. Pero sa mga students natin na master na ang multiplication table, I'm sure by now, alam nyo na yung factors na hinahanap natin. Pero to give you an alternative, ito yung ating application na lagi natin ginagamit, si Desmos. At si Desmos ang tutulong sa atin para makahanap yung ating mga factors by plugging in x squared plus 9x plus, minus 400. At yung ating graph, hindi nyo nakikita yung graph kasi masyado malaki yung graph natin. So, what you need to do is paliitin yung graph natin para makita nyo na boom and boom. So, ibig sabihin yan, yung factors natin, which is the opposite value ng ating mga solutions, would be positive 25 and negative 16. So, yan yung ating factors. At yung solution natin would be negative 25 and positive 16. So, paano natin gagamitin yan dito sa ating equation? So, ibig sabihin yan, yung factors natin, isang minus, which is yung opposite operation ng ating solutions. So, ito si 16. At yung positive would be yung negative dun sa solution natin, which is 25. Kasi negative 16 plus 25 is positive 9. Kasi kung nagkabaliktad yan, magiging mali ang ating sagot. So, ibig sabihin nun, yung solution natin will be x is equal to 16. And x is equal to negative 25. At sabi nga natin, since ang hinahanap natin ay measurements, lagi natin kukunin yung positive value ng ating x, kaya si 16 yung distance or 16 inches yung distance ng ating robot to the mineral water na meron tayo sa ngayon. So yan yung mga kailangan natin gawin sa pag-solve ng ating word problem involving similar triangles. So by cross multiplication, we're able to produce a quadratic equation na pwede nating i-factor, at kung nahihirapan kayo sa pag-factor, pwede kayong gumamit ng Desmos to help you out get the idea ng two numbers na kailangan natin. Otherwise, kung na-master nyo na yung inyong multiplication table na I'm hoping na-master nyo na by now, we know na ang factors na will be x minus 16 and x plus 25. And by zero product property, our solutions would be x is equal to 16 and x is equal to negative 25. And we know when we are working with a geometric problem, we need to use the positive values of our solutions dahil measurements ang hinahanap natin, kaya 16 inches ang length ng ating line segment AD na represented para sa pagkuha ng distance ng ating robot traveling towards the water bottle. So yan ang theorem ng right triangle na pwede natin gamitin sa pagsukat ng mga similar triangles. At sa similar triangle ninyo naman, hanapin nyo naman yung distance ng ating lake. Nakita nyo yan? Yan yung ating little lake. At meron tayong information about the right triangle dito sa ating mapa. So, paano nyo makukuha yung measurement ng width ng ating lake na yan given the information na meron tayo. At yan ang inyong number blender challenge of the day. Comment it down below kung ano ang computation ninyo. At yan yung lesson natin sa altitude at hindi attitude ng ating mga right triangles na pwedeng-pwede natin gamitin para mag-solve ng mga complex right triangle problems similar sa tinakil natin for today. And again, pinaka-importante pag-solve ng mga problems tulad nito ay yung tamang equation na makakatulong sa atin sa paghanap ng values ng x or ng y na hahanapin natin with this geometric problem. So this is Dr. E, and see you again next time. Bye!